In this video, we're going to talk about permutations and combinations. Before we do that, let's rank the top two TMNT. If you recall, there's 4 Teenage Mutant Ninja Turtles. So first, I have 4 to choose from. And then once that person is chosen, I only have 3 left to choose. So 4 times 3 is equal to 12. All right, let's take a look at another example. Suppose I'm offering to give 5 random people the following prizes from 7 people. Assume each person can only win 1 prize. How many different ways can I give away my money? Well, there's 7 different people that could win the $200. So that person can't win again. So then it's 6 people that can win the 100. That person can't win again. So then it's 5, 4, and 3. Multiply that, you get 25/20. These 2 examples are what are called permutations. A permutation is an ordered arrangement in which our objects are chosen from n distinct objects, and repetition is not allowed. Okay? And again, assume each person or item can only be selected once. So the permutation formula of n things taken r at a time is equal to n factorial divided by n minus r factorial. Well, let's take a look at the previous example about the money. This is an example of a permutation of 7 people chosen 5 at a time. So it would be 7 factorial divided by 7 minus 5 factorial, which is 7 factorial over 2 factorial. Remember, that's what? 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 2 times 1. They divide out. So 7 times 6 times 5 times 4 times 3, which we already know is 2,520. Okay, let's take a look at another example. So if 8 horses are racing, how many different ways can the top 3 finish? So we're taking n items taken r at a time. Order matters, first, second, and third, and I can select only each individual horse once. So this is a permutation of 8 things taken 3 at a time, which is 8 factorial divided by 8 minus 3 factorial, which is 5 factorial. Now, watch what I do here. This is the same thing as 8 times 7 times 6 times 5 factorial. Well, I have a 5 factorial on the bottom, so the 5 factorial on the top and the 5 factorial on the bottom can divide out, and 8 times 7 times 6 is equal to 336. Okay, let's take a look at a couple more. So now I want to do a permutation of 3 things taken 3 at a time. So let's write this out. That's 3 factorial divided by 3 minus 3 factorial. 3 factorial is 3 times 2 times 1. This is 0 factorial. Remember, that's 1. That's 6. So a permutation of n things taken n at a time. Well, 6 is 3 times 2 times 1. That's 3 factorial. So here it would be n factorial. Now, let's do a permutation of 5 things taken 0 at a time. That's 5 factorial divided by 5 minus 0 factorial. Well, that's 5 factorial over 5 factorial, which is 1. So a permutation of n things taken 0 at a time is 1. Now, you don't need to memorize the particular formulas. It's easy to use the permutation formula to figure these out. Okay, now let's talk about combination. So a combination of n things taking r at a time is a collection without regard to order in which r objects are chosen from n distinct objects and without repetition. Again, assume each person or item can only be selected once. And again, the difference between a combination and a permutation is combination, the order doesn't matter when it's selected, where a permutation is. So a combination of n things taken r at a time is the permutation of n things taken r at a time divided by the repetition r factorial. Well, permutation, that's going to be this over this, which again, as a complex fraction, is this. So again, I'll summarize here. The combination formula is this. Okay, let's take a look at an example then. So how many different simple random samples of size 5 can be obtained from a population whose size is 52? So we're taking n items taken r at a time. We know each individual person can only pick once, and here the order doesn't matter. So this is a permutation of 52 things taken 5 at a time, which is 52 factorial divided by, well, 52 minus 5 is 47 factorial, and then the r is 5 factorial. So we can write this out. So I'm going to write it like this. I don't want to go all the way down to 1, so I'm going to stop at 47 factorial. 47 factorial, 5 times 4 times 3 times 2 times 1. These divide out. So again, 52 times 51 times 40 times 49 times 48 divided by 5 times 4 times 3 times 2 times 1 is this. Okay, so suppose now I'm offering 5 random people prizes of $100 from 7 people. Again, assume only each person can only win once. How many different ways can I give away this money? This time around, we're taking n items, taking r at a time. Each person can only win once, and the order doesn't matter. Why? Because every single person is going to win $100, unlike the previous example where it was 5 different amounts. So this is a combination of 7 things taken 5 at a time, which is 7 factorial divided by 7 minus 5, that's 2 factorial, times 5 factorial. Write out 7 times 6 times 5 factorial, 2 times 1 for 2 factorial. The 5 factorials divide out. That's 42 divided by 2, that's 21. Okay, let's do a couple other combinations then. Combination of 10 things taken 10 at a time. That is 10 factorial divided by 10 minus 10. That's 0 factorial times 10 factorial. Well, 0 factorial, that's 1. The 10 factorials divide out, so it's 1 divided by 1 times 1, which is 1. So a combination of n things taken n at a time is 1. Then for a combination of 10 things taken 0 at a time, that's 10 factorial, 10 minus 0, that's 10 factorial times 0 factorial. Well, that's exactly the same as what we just had here. The 10 factorials divide out. 0 factorial is 1. This is also 1. So a combination of n things taken 0 at a time is 1. Okay, so sometimes we want to arrange objects in order, but some of the objects are indistinguishable. Okay? All right, so suppose you're playing Scrabble and you have 6 letters on your tile. You have 3 E's, you have 2 R's, and you have a T. How many unique 6-letter words can I create from these letters? So obviously we have 6 letters using all 6 letters, 6 times 5 times 4 times 3 times 2 times 1, that's 6 factorial. But here, it doesn't matter which E you use, whether it's E1, E2, or E3. Well, there's 3 times 2 times 1. That's 6 different ways to rearrange those 3 E's. So I would divide by the overlap, 3 factorial. There's 2 different ways to use the 2 R's. 2 times 1, that's 2 factorial. And then there's only 1 T. I could put 1 factorial because of the repetition. Simplify. So 3 factorials go away. So I have this. That's 30. That's 120 divided by 2. That is 60. This is an example of permutations with non-distinct items. So the formula in general is what? N factorial divided by n sub 1 factorial times n sub 2 factorial times n sub k factorial. So the order still matters, but we do have some repetitions that we can divide out. Okay, let's take a look at an example with this. So a baseball team consists of 3 outfielders, 4 infielders, a pitcher, and a catcher. Assuming the outfielders and infielders are indistinguishable, how many batting orders are possible? So again, with baseball, 9 people bat. So we've got 3, 4, 1, and 1. That's 9 factorial. The outfielders are indistinguishable. There's 3 of them, so divide 3 factorial. 4 infielders, divide by 4 factorial. And then there's just 1 pitcher and 1 catcher. Okay, simplify. Again, I'll stop at 4 factorial. Those divide out. 3 times 2 times 1 is 6. The 6 on the top and the 6 on the bottom divide out. So I'm left with 9 times 8 times 7 times 5, which is 2,520.